Hello again, 2 uploads, one after the other. Well, it'll actually be 3 once this is done. But hey, here we are. That's progress, right? Better than the hiatus that I've been on video-wise. I've been working on this, but I just haven't been filming it because I'm not very good at that. In any case, let me show you what I've done to make the electronics work. So here's the setup. In the center here is the Maytech SC or F405 SE flight controller. Now this is usually meant for quadcopters. However, it does have these servo outputs, which makes it compatible with wings. Now it uses the same firmware as the F405 SE wing that Maytech also used to make. They don't make this one anymore, but I have it, so that's what I used. Connected to that is this ELRS receiver with diversity antennas. I know it's not ideally set up, but this is kind of a rough and quick setup. And that ELRS receiver talks to my transmitter through this handy-dandy little module on the back of it. Meaning it's talking in Express LRS, and this has a custom firmware that allows me to have live telemetry data from that same receiver without having to plug in extra electronics and spend extra money, which is great. And with the ELRS receiver set up the way it is, I can plug in a USB cable from the back of my transmitter, specifically into the ELRS module, and into my computer. I promise it goes down there, and into the flight control software at the ground control station, GCS. Now, the only problem is it's very slow. I haven't yet figured out how to fix that, but I will eventually. But I am getting a live feed. Now, naturally, those are not all correct. Those are rough readings. Yeah, because I don't have a GPS and it's going off of barometric pressure, that altitude is not correct, and the yaw might be, but I don't have a compass on there. Now you might be saying, but hey, weren't you going to put a GPS on this thing? I was. I had every intention of doing so. However, due to time constraints, I have not been able to do so, because I wanted to get this thing flying before I threw a GPS on it, and flying well. And because I didn't get to do that due to weather and another drone I had crashing, along with homework and finals, I have not had the opportunity to fly this drone. But on the plus side, I'm able to test everything on the ground that I have access to and prove that this is in fact working. Like, I know the flight controller works. That's not a question. I can hook that up to the computer directly and show that that is moving correctly. However, the thing I want to show you is that the telemetry is working, because that was the biggest hurdle in this project. I will show you that I am in fact getting a telemetry connection from the ELRS receiver to this ground control station. The way I'm going to do that is by showing you my artificial horizon. There's another fancy acronym for that. I don't remember what it is. So, here is the aircraft connected by a battery. Don't mind that cable. That's what hooks up to my headset here. So this is just powered off the battery. There's no USB cable going from the plane to the computer. So what I can do now is tilt this for a second, and then put it back. Now we go back to the computer. And you might think, well, didn't we just miss it tilting? Not so. This has quite a long delay. Like I said, I still need to fix this, but this has a long and large amount of latency. This is still pretty slow for that though, so it's probably still trying to load parameters and things. Yeah, the compass isn't healthy, we don't have one, but that's besides the point. To say, I am in fact getting a live feed from the ELRS receiver, even if this is being super slow and you can't see it, at least through the artificial horizon, but I am getting a live feed of data. When using ArduPilot to set up a Tailsitter or any kind of a VTOL, you're going to be working off of the arduplane firmware, which is not the same as the arducopter firmware or the Ardu rover. Arduplane is what you're working off. Now, normally you'd say, but if it's just a plane, how would it enable VTOL? Isn't a multi-rotor like arducopter built for VTOLs? yes, that's built for VTOLs, but not fixed-wing VTOLs. And so there's a couple of things you have to change on the arduplane firmware in the parameters to get your plane to behave like a VTOL. And it's all covered on these hundreds and thousands of pages of documentation. But basically, we have all these different types. So first what we have to do is enable Q-plane. And now that I have the airplane hooked up directly to the computer with a USB cable, I can give you a very fast live feed into the telemetry data coming off of the flight controller. So there's a couple errors on there. We're going to ignore those for now. What we're going to do is we're going to go to our config and our full parameter list. And I won't go through everything I do to set this up, but I will show you the general idea. So we're going to go... That's not it. We're going to go Q Tailsit. And normally before you enable this parameter, you only have a couple of things. One of these is QSit enable. So I click on this, I tell it 1, which gives it a value of enable, which turns on all these other settings to do tailsitter stuff. So basically telling this, okay, you're not just a flying wing, you are also a VTOL. And now that the drone knows it's a VTOL, we can go on to the next thing, which is laying out our motors, which we then adjust by going to this parameter, Q tailsit motor mix. And then we have a lot of options for this one. This specific number equates to having a quad motor setup, like I have on this plane. And the reason that is because I have 4 motors. If I was doing 2 motors, it would be a totally different number, which is what most tailsitter VTOLs do. But in our case, quad motor it is. Alright, now that we're back in the data list, I changed our flight mode into Q stabilized. Now, there's a lot of different flight modes: stabilized, manual, auto, etc., etc. And those all work with their respective firmwares. But since this is a VTOL plane, we have the regular flight mode, stabilized, auto, manual, but we also have Q stabilized, Q auto, etc., etc. There are a few flight modes that don't translate over, but this is the general idea. Now, if you notice, it looks like it thinks our plane is upside down. It's not. But we're in Q stabilized mode, which stabilized is a multi-rotor flight mode, meaning that our drone right now thinks it should be in quad motor mode. And if it's in quad motor mode, that means that its motors and the nose need to be pointing that way. So, as I rotate this up, and not snag motors on things, oh, would you look at that? All of a sudden now we're level. And we're pointing with the motors up. Now, obviously, we can't stay in this orientation to be able to fly in fixed wing. So we have to switch flight modes, which I do with my handy dandy switch. Now we're in fly-by-wire A, which is a stabilized fixed wing flight mode. Uses a lot of input to the computer, and then the computer decides what to do with those inputs. But now, to get back to level, we have to be pointing forward instead of up. And that's how that transition happens. Truly, as with pretty much anything, there's a lot more that I could cover. However, that's the basics. You set this up like an airplane, you tell it to enable the tailsitter mode, and then you tell it what motors you're using and what servos you're using, and it will tell itself, okay, when we need to hover like a quad, I want to point up, and when we need to fly forward, I want to point forward. And that's how you set up, basically, the tailsitter. Like I said, there's a lot more to go into, but I'm not going to do that here. So, I will see you in the last video on this specific airframe, and I'll explain why it's just the last one for this airframe.